Okay, we're going to go through logarithmic functions. We'll go for a quick basis, and then we'll just talk about transforming log base 10, which is a very specific one, and it's the one we use to solve things. First off, we'll talk about how they're related to each other. Log functions are related to our exponential function. So, for instance, this, I know I'm not drawing it perfectly, is roughly exponential growth, right? We'll just say that maybe that was y equals a to the power of x, right? It has a horizontal asymptote at our x-axis, right? We know that with our exponential function, it'll never hit our x-axis, okay? What happens with the log is like we invert it on a 45-degree angle. So you remember when we do the inverse of a function? This is the inverse of our function, okay? So what happens is for the log function, the horizontal asymptote now becomes a vertical asymptote, okay? So for the log function, it will never touch the y-axis, okay? And we'll just do the log function in blue here. And it has this type of effect where it's growing and then kind of takes off like this. Okay, so it's almost like we've inverted on a 45-degree angle. The best way they use to represent it is like f at x log. So this would be our f at x is equal to log a at x. Okay, so this is the inverse of the function. And what we're going to focus on is like kind of key points to it. And we won't say why, we'll call this one f at x2 so that they're similar to each other. Okay, so we're talking about the inverse of our exponential function. The same thing happens if it's with decay, and we'll quickly show decay because that was exponential growth, right? We know that this is when an exponential function is getting larger. Well, we also have when exponential functions are getting smaller, and we can also recreate that. We'll do that on the same type of axis here. Whoops. Let's do. All right, so we have our xy axis. Exponential decay is when we're coming down and then getting ever so close to the x-axis but never really touching it. It's the same idea. This is still an f and x is equal to, say, a to the power of x, right? Well, because this is the inverse of this function, it's the same type of idea. We're flipping it, okay? This one still had a horizontal asymptote on the y-axis, the x-axis. This is our exponential function for exponential decay. So we have a horizontal asymptote across here. When we invert it, we then get a vertical asymptote once again. So the vertical and horizontal asymptote, nothing changes there. The only difference is the way that this function approaches. In this function, because of decay, this one is coming across and it's cutting down. So it looks a little different. We'll do it in purple. What's happening here is the y is still a vertical asymptote, but this one comes down and cuts up kind of like that. Okay, so it's very different looking than the above one. The above one is much easier to recognize in terms of like a mirror image. This one, because of the decay cutting through it, makes a very different type of look. Okay, so we just got to be aware of where our asymptotes are with our logs. And this one would again would be our f at x is equal to log a x. Okay, so this is for decay, and this one's for growth. Now, what we're going to focus on is a specific one. We're going to look at log base 10. And log base 10 is drawn with specific coordinates. Okay, and those coordinates become very important. And first of all, log base 10 is the inverse of the function. Does it have it here? So, yes. F at x is equal to 10 to the power of x. Okay. So what we're going to do is we're going to recreate that, and then we're going to go through recreating the inverse of this function. So when we're on the negative values of our x, So we have our xy axis here. When we're on our negative values, we know we're very close to the x-axis, okay? It slowly builds, builds, builds. Now here's an important part, and we'll say that this is 1 for now. When x is equal to 0, what is this function equal to? Do you know off the top of your head?
Is it 1?
Yes, it's going to be equal to 1. So when we're on this x-axis or the y-axis here, that's when the function picks up and it goes to 1. Then from there, x to the power of 1 will be 10, x to the power of 2 will be 100. So it really picks up and it takes off like this, okay? So we have that important part there. And we can talk about some of the important parts. We'll just say that this is when it's 1. Well, we know that's when y is 10, okay? And if we're at 2, that's when it would be 100, okay? So it'd fly way up there. The other idea, and we'll do a little t-chart, so this helps make a little sense for us, okay? So we have those values. We already know that when x is 0, our y value is 1. When x is 1, it's 10. When it's 2, it's 100, right? Well, what about when it's negative 1? Negative 1 is when we are going to invert this, right? That's if this becomes 10 to the power of negative 1, it's also equal to 1 over 10. In other words, a tenth, okay? So that means at negative 1, this value down here is essentially 1/10, or 0.1. That's the idea, okay? So these are some major points we just kind of want to keep in mind when we go to invert this, okay? We know that we have what? A horizontal or vertical asymptote for this exponential function.
Horizontal.
Yeah, we have a horizontal asymptote, right on the x-axis. Okay, well, let's say we go to invert this now. When we go to find the inverse of this function, the inverse of this function is written at f at x is equal to log 10x. Okay, so let's try to keep an idea of how these points are going to flip. Okay, so we've written them down here. We now have what? A vertical or horizontal asymptote with our log.
Vertical.
Yeah, this becomes a vertical asymptote, right? So through here we have a vertical asymptote. So with that being the case, essentially what's happened is our y values now become our x values, and our x values become our y values, right? So let's say we find this was for our 10 to the power of x. Let's say for our log 10 to the x, what are our x and y values going to be?
1/10 and negative 1.
That's right. So we're now going to have a tenth as our x value and y being negative 1. So when y is negative 1, we'll say that's roughly here, right? That's when our x value is a tenth. Okay, so that means at this point here, right? So we'll say that's a tenth. And we'll change the color of this guy. We'll put him in blue. So there's one of our coordinates, right? What's another one of our coordinates going to be?
1, 0.
Yeah, so it's going to be 1 and 0. Well, at 1 and 0, we're talking about here, okay? And that's where this point is inverted from that one. The next one's going to be what?
It'll be 10, 1.
10 and 1. So if we were to jump across this, we'll say that this is roughly 10. We know it's not quite the scale, okay? And this is 10 and 1 here. And then the other one would be 2 and 100, right? So in other words, here's the general idea. We're very close to the y-axis. And then when our y value is 0, we're hitting our x-axis. And then it takes off very quickly in this direction. Okay, so that's our log base 10. So that's the general idea for graphing basic forms of logs. That's how they relate to each other. Okay. Next, what we're going to do is transform these so you can see how to move them with those major points.